Hello viewers, welcome to EF channel. Today we are going to discuss about the complexity theory. Topic of today is halting problem undecidability. How can I prove it? So in my previous video I already explained you what is halting problem, and we know that halting problem is undecidable. Question is how can I prove? And we know that by using the contradiction, we can prove that in three steps that halting problem is undecidable. How? In the first step, we have just an algorithm. We assume that there is an algorithm that can prove that halting problem is undecidable. So here halt is taking the program P with W input, and inside of it we have a boolean result, and we know that the halting problem doesn't have any algorithm. So in the inner how the inner halt is working, but we assume that we don't know how the inner halting is working, but we assume that it will stop when the output is yes, if P halt on W input, no otherwise. So depending on the termination, it will give a result a yes or no. So how the algorithm is working here means the program halt takes the program P and W input as input parameter. When the algorithm halt, it will return the value 1, while the algorithm loop, then it will return the zero values. Now in this step it is just an algorithm. We are assumed that we have an algorithm for the halting problem, while in reality we doesn't have any algorithm. So in the next step what we are going to do, we are creating another algorithm with which is called absorb function. With this absurd, we are taking the program P as input and we are called algorithm halt inside it, and then negate the result of halt, which means that absorb is does the opposite of what actually the halt is doing. So how it is happening. So let's see. Here we have boolean absorb. Inside of it we have program P, which passes the input P, and we have boolean A. A is a variable here. A, let's say, equals to A is equals to halt PP, which means halt P is means halting problem, with which have our algorithm for program P, is running our algorithm for program P for the halting problem. And the second P is along with the input program uh, P. So once it is run, the program with itself is run as input. After that, if A means a halt PP is equals to yes, then the absorb is going to inside the infinite loop. Else halt P is returning the no. In that case, the absorb is returning 0. What it means? It means that when A is equals to A is returning the yes, then the absorb is going to infinite loop. So it is not terminating. Else the parameter will return 0. In that case, the absorb program will stop. So what is actually means? It means that yes parameter set by A is equals to absorb goes infinite loop, else it halts. The absorb function does exactly the opposite what the halt is doing here. That is actually done by this program. So far so good. We can see that Simply, if P terminates with itself, then the halt PP is saying yes, means halt PP will terminate, and it will return the absorbed P is stuck. So it will return no, then absorbed P, it will return the absorbed P is equals to no, and it will stuck. Otherwise, if P does not terminate with itself, then halt PP is no, means halt PP will does not terminate, and that case the absorbed P will return as the yes, which is actually means the termination of absorb. Question is any contradiction so far? Answer no. We just create a program that does the opposite what halt is doing. There is another question, what is the input at absorb? In the second step, it can be any program that take as input. See, here we have the program P as input, which passes as input inside of the Boolean absorb. Now, in the third step, what is happening actually? Third step, we are going to take input absorb on absorbed function. So how do we get the contradiction? What are the running and what we are get on the contradiction? We get the contradiction by passing the absorb itself as input by absorb function. So for we are going to run absorb as input at absorb function. In that case, the absorb with itself, which will create contradiction at the third step. Then we will see that absorb terminates with itself, then halt absorb will return the yes output, which means that absorb will say is terminate. It is terminating when the absorbed is equals to saying no, means it will not terminate. And otherwise, if absorbed does not terminate with itself, in this case, absorbed absorbed will say no, means that halt does not terminate, and in that case, absorbed will return as the yes, which means that it is terminating. So finally, we get a clear contradiction that absorbed absorbed is equals to does not terminate here, means like absorbed does not terminate with itself if absorbed does terminate. Otherwise, if absorbed terminate with itself, then absorbed does not terminate. This is clear contradiction. We conclude that our assumption was wrong. There is no algorithm that can solve the halting problem. Thank you for watching this video. In the next video, we will see how the Rice's theorem explaining undecidability. Thank you for watching this video again. See you again.